So are you trying to understand how to work with operators in Java? If so, this video is for you. So in this video, I will go over topics related to Java, including an introduction, arithmetic operators, relational operators, bitwise operators, logical operators, control flow statements, operator precedence and associativity, as well as some coding examples. As always, this video is timestamped, so if there's a specific topic that you came for, you can skip to that section. So let's get right into it and let's talk tech with Tyler. So the table provides a brief overview of different operator types in Java, their descriptions, and example usage. So the arithmetic operator is used to perform basic mathematical operations on numerical data types. And these include addition, subtraction, multiplication, division, modulo, basically PEMDAS, if you guys know PEMDAS. They enable us to manipulate numbers and perform calculations within our programs. Another operator is the relational operator. So relational operators compare two values and return a Boolean result of true or false, 0 or 1, y or n. These operators include equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. They play a crucial role in decision making and control flow statements. Another operator is the logical operator. So logical operators are used to combine Boolean expressions and determine the truth value of compound conditions. The logical and logical or operators enable us to make complex decisions based on multiple conditions. The assignment operators are used to assign values to variables. The basic assignment operator equals is fundamental. And there are compound assignment operators such as plus equal, minus equal, star equal, percentage equal that combine operations within assignments. Bitwise operators perform operations at the bit level. They include bitwise and, bitwise or, bitwise exclusive or, bitwise not, left shift, right shift. These operators are useful for low-level manipulation of individual bits. Conditional operators are a compact way to write simple if-else statements. So the increment/decrement operators are used to increase or decrease the value of a variable by 1. They're commonly used in loops and calculations. I use them in the for loop a lot. Shift operators perform bitwise shifts of the bits in a value. So the left shift and right shift operators shift the bits left or right by a specific number of positions. The instance of operator is used to test whether an object is an instance of a particular class or interface. It returns true if the object is an instance of the specific type, otherwise it'll return false. The unary operator works on a single operand and are used to increment or decrement, negate, and perform logical not operations. So operators are essential tools in Java for performing a wide range of operations on data. They enable us to manipulate variables, make decisions, perform calculations, and work with bits. So understanding the different categories of operators and how to use them effectively is key to writing efficient and expressive Java code. So when working with arithmetic operators in Java, it's essential to understand two important concepts: operator precedence and associativity. So in this slide, I have a list of arithmetic operators that are commonly used along with their description and example. So the first concept is operator precedence. And operator precedence pretty much determines the order in which operators are evaluated in the expression. So it defines which operators take precedence over others when multiple operators appear in the same expression. Similar to in elementary when I was learning precedence, I remember PEMDAS, and it's the same thing. So the general precedence order from the highest to lowest for the arithmetic operators is as follows. So the first is parentheses, then unary operators, positive, negative, increment, decrement, then multiplicative operators, and then additive operators. And keep in mind, to alter the default precedence, you can use parentheses to group expressions. The second concept is operator associativity. So this determines the order in which operators of the same precedence are evaluated when they appear sequentially in an expression. It can be left associative or right associative. So Left associative is operators are evaluated from left to right, whereas right associatives, they're evaluated from right to left. So keep in mind, in Java, most arithmetic operators, including addition, subtraction, multiplication, and division, are left associative, meaning that when operators of the same precedence appear in a row, the evaluation proceeds from left to right. However, some operators, such as the assignment operator and the conditional operator, are right associative, which will evaluate from right to left. So just understanding both operator precedence and associativity is crucial for writing correct and predictable expressions in Java. Using parentheses judiciously can help you control the order of evaluations and ensure that expressions are evaluated as intended. So let's discuss relational operators and how they are used in control flow statements like if-else and loops in Java. So relational operators are used to compare values and determine the relationship between them. So they return a Boolean value, true or false, based on whether the comparison is true or false. So in Java, the relational operators are as follows. So we have the equal to, which is two equal signs. We have the not equal to, which is an exclamation sign and an equal sign. We have the greater than, less than, greater than or equal to, as well as the less than or equal to. So relational operators are commonly used in control flow statements to make decisions and control the flow of the program. So two common control flow statements where relational operators are used are the if-else statements, which allow the program to execute different blocks of code based on a certain condition, as well as loops, where loops allow repeated execution of a block of code based on a certain condition. So relational operators are often used as loop conditions to control the loop's execution. So relational operators play a critical role in creating logic and controlling the behavior of programs. They allow developers to make decisions based on the relationship between values and to create efficient loops for repeated execution. So proper use of these relational operators in control flow statements is essential to ensure accurate and robust program behavior. So similar to my previous slide, this slide kind of goes a little bit more in detail of relational operators and control flow statement. So it gives the control flow statement, it'll give the use of relational operators. What are they useful for in the control flow statement, as well as an example. This table has the operators, a description of it, an example, as well as the impact of short circuit evaluation. So for the ampersand operator or the logical and operator, it'll return true if both operands are true. Whereas the logical or operator will return true if either operand is true. And the logical not operator, it just reverses the logical state of the operand. So an example that I have right here is Boolean result equals condition 1 and logical and conditional 2, logical and condition 3. So for the result to return true, all three conditions must be true. So with the impact of short circuit evaluation on logical operator usage, it's primarily seen in terms of efficiency and preventing unnecessary evaluations. So by evaluating operands from left to right and stopping as soon as the final result is determined, short circuit evaluation can optimize code execution by avoiding unnecessary computations. So for the logical AND operator, if the left operand is false, the right operand is not evaluated because it cannot change the overall result to true. So let's go back to that example at the bottom of the screen. Boolean result equals, if condition 1 is already false, the whole result is going to be false. And we could just stop evaluation right then and there. And then for the logical OR operator, if the left operand is true, the right operand is not evaluated because it cannot change the overall result to false. So back to the Boolean result equals, if condition 1 is true, the result is already true. You don't have to go executing condition 2 or condition 3. So on this slide, I detail and describe some bitwise operators. I give the operator, the description, its application, and an example. But you may be asking, is this necessary to know? Is bitwise operators used in Java code frequently? So bitwise operators are not as commonly used in everyday Java code compared to other operators that I mentioned, like arithmetic or logical operators. The usage of bitwise operators is typically seen in specific scenarios where bit level manipulation or optimization is required. So some common areas where bitwise operators are used include 1. Low-level programming. So bitwise operators are commonly used in low-level programming tasks such as working with hardware interfaces, manipulating individual bits and registers, or implementing custom protocols. Second area where bitwise operators are used is bit flags and bit masking. So bitwise operators are used to manipulate flags or options represented as individual bits within an integer or other integral data types. So this approach is often seen in system configuration settings, permissions, or state management. A third is performance optimizations. So bitwise operations can be leveraged for performance optimizations in certain algorithms or data structures. So for example, using bitwise operators can enable compact storage of data or efficient bitwise computations. So it's up to you to whether or not you want to kind of try to understand this. It is helpful, but it's not used as often as the other operators that I discussed. So next up is operator precedence and associativity. Operator precedence determines the order in which operators are evaluated in an expression. So operators with higher precedence are evaluated before operators with lower precedence. When multiple operators have the same precedence, the associativity of the operators either left to right or right to left is considered. So we went over operator precedence kind of 1 through 4. So this is a little bit more helpful if you have a large coding snippet and you want to know what is going to be executed first. This table will be helpful to kind of understand the precedence of all of these different operators. Relational operators are used to compare values and determine their relationship. They return a Boolean value, which is either true or false, based on the result of the comparison. So in Java, the relational operators are, we have equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. So now that we have this note here up top, we're going to just work on some examples. So we have int a equals 5 and int b we're going to say is 10. We'll paste some examples to work through. All right, so the first one, result 1. We have Boolean return 1 equals a equals b, which means a is equal to b. What do you think this would return? False. A is not equal to b. 5 is not equal to 10. Is a not equal to b? That's true. That'll return true. Is 5 greater than 10? That is false. Is 5 less than 10? That is true. Is 5 greater than or equal to 10? That's false. And is 5 less than or equal to 10? That is true. So there are a few control flow statements that I will cover in this example. One of them is the if statement. So the if statement is used to execute a block of code if a specified condition is true. So let's do the same thing with age. Int age equals 20. As you may know, in the United States, you're legally allowed to vote if you are older than 18. So let's just say if age is greater than or equal to 18, and let's just print something out. You can vote. And basically what this does is if the age is greater than 18, greater than or equal to, which it is, they can vote. And next up, we will work with the if-else statement. So the if-else statement is used to execute one block of code if the condition is true and another block if the condition is false.
Hey y'all, I'm currently editing right now and I just wanted to let you know on line 32, we will put a closing bracket to close that if statement.
So let's create an int of marks. And let's just say it's 75. We'll do an if statement. If marks greater than or equal to 60, what do we want to do? we'll print that they passed the exam. Else, we will print that sadly you failed the exam. So next up is the nested if statement. And you could use the nested if statement to create multiple levels of conditions. So let's set another number, int num equals 10. And if num is greater than 0, then we're going to do something. So within this if statement, we're going to have a nested if statement. If num modulo 2 is equal to 0, that means it's an even number. So we will say the number is positive and even. Else, the number is positive. Oops, I cannot spell today, you guys. Is positive and odd. So we have our if and then our else. And then within that, we're gonna go out of that nested if statement, close it, and then do an else to close out the original if statement. The number is not positive. And that's all. And now we will cover the switch statement. So the switch statement allows you to perform different actions based on the value of a variable or an expression. So I have an integer variable called day, and it's set to 2. And then we will have a string called day name. And to start a switch statement, you have to use the keyword switch and the variable that you want to have as the condition. So for this case, it's day. And then we just start with cases. So case 1, day name equals Sunday. By the way, is that like a official thing? Like, do the weeks start on Sunday? Or is that just a me thing? I will stop here after Wednesday. And let's add a semicolon here. So we'll just continue the cases, and then we could also have a default case. So for this one, we'll say default keyword, day name, invalid day, and break. So it's helpful to have a default switch just in case any of the cases that you created don't occur. This default will occur. And then let's just print out today is and plus day name. Not today's, today is, and then day name. So that's the switch case statement. Next up is the while loop. So the while loop executes a block of code repeatedly as long as the specified condition is true. Let's do another example. Int count equals 1. And let's start this while loop. So while keyword, condition,
while the count is, let's say, less than or equal to 5. What are we going to do? We're going to print out count plus count and count plus plus. So what this does is it's going to start with count equals 1, go through the while loop. So count is less than or equal to 5. That's true. So it'll print out count and then count, which is going to be 1. Then it'll increment that 1 to 2, print out 2. It'll print out all the way up to 5 because we have the less than or equal to operator. Another loop is the do while loop. So the do while loop executes a block of code at least once, and then it repeatedly executes as long as the specified condition is true. So let's declare another variable, int I equals 0. And let's start this loop. So do, what do we want to do? We want to print out index plus I plus plus, increment, and then while, that's the next keyword for the do while loop, while the condition. So what's the condition that we should set? Let's say while I is less than 5. Alrighty. Another loop that we will go over is the for loop. So the for loop is used for executing a block of code repeatedly for a specific number of times. So let's set this up. For, we have initialization, int I equals 0. We have the condition. So let's just say I is less than 5. And then we have the incrementation, so I plus plus. And what are we going to do? We are going to print out the index. To sum this all up, relational operators and control flow statements are fundamental concepts in Java programming. And by using relational operators, you can perform comparisons and make decisions in your code. Control flow statements such as the if, else, switch, while, do while, and for loops help you control the execution flow and create powerful and flexible algorithms in your Java programs. Understanding these concepts is essential for writing effective and efficient Java code. All right, so let's discuss logical operators in Java, including the logical AND, logical OR, and bitwise OR. So we'll start with the logical AND operator, which is used to combine two Boolean expressions. It returns true only if both expressions are true. Otherwise, it returns false. So let's create two Boolean variables. Boolean A equals true and Boolean B equals false. So for the logical AND operator, we will initialize our Boolean result equals A and B. And what do you think this will return? Correct. It'll return false. Only if both expressions were true, it would return true. Otherwise, it automatically returns false. And as you can see on line 6, Boolean value B is false. So this will just automatically return false. So the logical OR operator is commonly used in conditional statements to check multiple conditions and execute code accordingly. So the logical OR operator is used to combine two Boolean expressions. It returns true if at least one of the expressions is true. Otherwise, it'll return false. So let us use this coding snippet. Let's copy and paste, and let us change this to the OR. So what do you think this is? What do you think result is equal to? Correct. It's true. And it's true because we have Boolean value A, which is true. So therefore, this is true. Let's do another example. So let's say we have age equals to 25 and Boolean, and let's name this is student. And let's just set it as false for now. And let's do an if statement. So if age is less than or equal to 18 or is student equals true, which we could just have as is student, that'll automatically set to equals true. We will system print line, you get a student discount. Because at least one of those are true. They're either less than 18 or they are a student. Else, you do not get a student discount. So that's just another example for you all. Alrighty, so bitwise OR. So the bitwise OR operator is used to perform bitwise OR operation on the individual bits of the operands. So this is a little bit more detailed. So we have int a, and let's set it as 5. And just in case you don't know, the binary value for 5 is 0101. Int b equals 3, and the binary value for that is 0011. And int result equals the A or bitwise or B, which the binary for that would be 0111, which is decimal for 7. So unlike the logical OR that we set up top here, the bitwise OR operator performs OR operation on each corresponding bit position and does not short circuit the evaluation. So it's essential to differentiate between the logical OR operator and the bitwise OR operator. The logical OR operator short circuits the evaluation. So it stops evaluating further as soon as it finds a true value, while the bitwise OR operator performs the OR operation on all bits, irrespective of the outcome. So logical operators in Java are powerful tools to create compound conditions and make decisions based on multiple Boolean expressions. Understanding how to use these operators is important for building robust and efficient control flow statements in your Java programs. Additionally, the bitwise OR, which honestly is a little bit less used, thankfully, is used for bitwise operations, which are different from logical operations, and it's essential to use them appropriately based on your specific needs. So now we are going to answer these 3 questions related to Java operators. So the first question states, write a Java program to swap the values of 2 variables without using a temporary variable. Think on that. So we'll create a class called swap variable. And within that class, we will create a main method. And let's create the 2 variables. So int a, we'll say it's 5, and b equals 10. And so we have to swap the values without using a temporary variable. So how can we do that? So we have a equals to 5, b equals to 10, and we want, after a swap, to have a equals 10, b equals 5. So one way is we will say a equals, let's do a little bit of math. So a equals a plus b, which is 5 plus 10, which is 15. So B is going to equal A minus B. So now A is equal to 15. So we have 15 minus B, which is 10. So that makes B equal to 5. And then now we could change A from A minus B. And that'll be 15 minus 5, which equals to 10. So now we have the swapped values. We have B as 5 and A as 10. All right, question 2. Write a Java program to check if a given number is even or odd using the modulus operator. So we'll create a class called even odd checker. And within that, we'll create our public method. So we're going to check if a given number is even or odd. There's many ways to get this number. We could use the scanner method to scan in a new number. But what I'll do is I'll just create that number right now. Let's say it is 9. So let's use an if statement. If num modulo 2 is equal to 0, this is an even number. Else dot out dot print line this is an odd number. And that's the Java program. That's the simple Java program. All right, question number 3. Write a Java program to calculate the area of a rectangle using the values provided by user. So this one specifically states values provided by user. So let us first import. What do we need to import? The java.util.scanner. And don't mind the underlying. This is just because of the placement of this import statement. All right, so public class, let's call it rectangle area. And we will copy this line since we're going to create a new main method. And within this main method, we will scan. So scanner, and let's just call it scanner, equals new scanner, system dot in. All right, and I'm just going to copy this system.out.print line just to make it easier on me and you. Enter the length of the rectangle. Double length equals scanner dot next double, and this will just take in the next double that user inputs. And system.out.print, let's get the width. So enter the width of the rectangle. Double width equals same thing, scanner dot next double. And let's calculate the area. So double area equals length times width. And that's how we will get our area, and we could just print it out now. The area of the rectangle is plus area. So these three examples cover different aspects of working with operators in Java, including arithmetic operations, conditional checks, and basic calculations. So feel free to modify and even expand upon these examples as needed.
All right, so that's all that I have for this video. I hope this video was helpful. I hope you understand a little bit more on how to work with operators in Java. I hope the coding examples were helpful. And if you have any questions or comments, or if you have any specific requests for my next tech video, let me know. Leave a comment in the description. Also, I do sell one-page cheat sheets that has all the information that I went over and showed in this video in a one-page document. And what's nice about it is that it's super cheap. So if you want to check out this cheat sheet, head to my website. It's in the description, but it's tylerlcrawford.com. All right, thank you for watching. I hope you enjoyed this tech talk, and I'll see you in the next video.